Hi everybody, Miss Lauschke here. I felt bad because I didn't get to go over this entire homework set with you, so I decided to go ahead and talk about 19 to however long this goes. So f prime of 4, you're thinking about if at this point right here we looked at a tangent line, what would the slope of that tangent line be? Well, that tangent line would actually be the function line here. So it's going to be equivalent to whatever the slope of this function is. So if I started here and went to here and went up 1 and over 2, I would see that that would be 1/2. So this derivative at 4 is 1/2. For which values of x is f prime of x less than 0? Well, it is exactly 0 from 0 to 3, right? From x equals 0 to x equals 3, it's exactly 0, but it doesn't have an equal to sign. It's positive from 3 to 5. It's also positive from 5 to 7. At 7, it's 0. And then starting at 7, you've got negative slopes of tangent lines to 9. So this would be for values between 7 and 9. And show that f prime of 3 does not exist. So you would want to show that the limit as h goes to 0 from the left of f of 3 plus h minus f of 3 divided by h, you're going to show that it does not equal the limit as h goes to 0 from the right of f of 3 plus h minus f of 3 divided by h, okay? Because you're trying to show that the left-hand limit does not equal the right-hand limit. So we've got the limit as h goes to 0 from the left. Now remember, this is a piecewise function, okay? So I'm approaching 3 here. My function, if I was going to write this function, it would be 1 from 0 to 3. It would be, if I went down 1 over 2, down 1 over 2, I think it's going to be 1/2 x. Let's just try it real quick. 1/2 x minus 1/2. Let's put a point in and see if it works. So if I put a 5 in, is it going to give me a 2? So 1/2 times 5 minus 1/2. Y equals 5/2 minus 1/2. Y equals 4/2, which is 2. So yes, so this is 1/2 x minus 1/2. Sorry, I accidentally put a little dot there. And that is for x between 3 and 5. And then some sort of parabola. I'm not going to continue there, but what I wanted to show you was when we do f of 3 plus h, with h coming in from the left, okay? So if I'm coming in from the left, if I'm approaching h from the left, I'm talking about negative 0.1 or negative 0.01. And so that leads me to the less than, right? So I'm actually, my f of 3 plus h at that point is 1. And then minus my f of 3. Well, f of 3 is f of 3. And f of 3 is 1. Okay? So this ends up just being 0. And that makes sense because look, the slope coming in from the left is 0. And then we're going to look at the limit as h goes to 0 from the right of f of 3 plus h minus f of 3 divided by h. I'm going to erase that. And so this one, limit as h goes to 0 from the right so if h is like 0.01, I'm going to be to the right, right? So I'm going to be at 1/2 x minus 1/2. So this is going to be 1/2 times 3 plus h minus 1/2, and then minus f of 3. Well, f of 3 is 1. So we've got 3/2 plus 1/2 h, or h over 2, minus 1/2 minus, if you want to, you can make it 2/2. So you can add those fractions. The limit as h goes to 0 from the right. So now we've got 3/2 and a negative 3/2. All we're left with is h divided by 2, and then division by h over 1 is multiplication by 1 over h. This becomes 1/2. Okay? So now you can see that the limit as h approaches 0 from the left of f of 3 plus h minus f of 3 divided by h does not equal the limit as h approaches 0 from the right of f of 3 plus h minus f of 3 divided by h, comma, therefore, my 3 dots mean therefore, f prime of 3 does not exist. Okay, I know that's a lot of work, and I know it's confusing because f of 3 is f of 3 no matter what. So it was always going to be 1. But f of 3 plus h is going to be different if you're coming in from the left or from the right. So that is how you would write those limits. Okay, is f continuous at x equals 5? It's continuous, yes. So yes, it is. You shouldn't use the word it. We learned that when we were talking about how to write the response to a free response. Yes, f is continuous at x equals 5. We know this because f of 5 equals 2, and the limit as x approaches 5 from the left is equal to the limit as x approaches 5 from the right is equal to 2. Which is larger, f prime of 5.5 or f prime of 6.5? Okay, so look at 5.5. Here's 5.5. And so the derivative at 5.5, I'll use a different color, is the slope of this line. It is a positive slope, okay? The derivative at 6.5 is also positive, but look how it's like flatter. This derivative at 5.5 is a lot steeper, and it's going to be bigger. So the derivative at 5.5 is larger than the derivative at 6.5 because it's a steeper slope. I should say steeper positive slope, because that matters too. Where this one is more, it's flat, it's a flatter positive slope. Okay. Number 24. If the limit as x approaches 3 of f of x is 9, which of the following must be true? So we know the limit's 9, okay? So what could be happening is it could have this situation going on, or it could actually be 9, right? It could actually equal 9, okay? But just because the limit exists does not mean that you have continuity. So which one must be true? It does not have to be continuous there. So that one does not have to be true. Does it have to be differentiable? Well, the limit exists, but there could be an open circle, and if it's not continuous, it's not differentiable. So that definitely does not have to be true. And f of 3 equals 9? No, it could equal something else up here. Does not have to equal 9. So really, none of these have to be true. Okay? At x equals 2, the function given by g of x equals 2x when x is less than 2 and x squared when x is greater than or equal to 2 is. So we want to find out what is f of 2. F of 2 is 2 squared, which is 4. What is the limit as x approaches 2 from the left? And from the left, we would be talking about 2x, and so that would be 4. What is the limit as x approaches 2 from the right? From the right, it would be 4x squared, so 2 squared is 4. So therefore, your limit as x approaches 2 of, I said f of x, sorry, it was g, of g of x is 4. And then, so that was my number 1, that was my number 2. Here's my number 3. My g of 2 equals my limit as x approaches 2. So therefore, it is continuous. So we know that it's continuous, so that's going to cross that one out, and it's going to cross that one out, because this one said not continuous, and we just proved it was continuous. And this one says neither continuous. We just proved it was continuous. So we're going to cross out both of those. Now we're down to, is it continuous but not differentiable, or is it continuous and differentiable? So now you have to think about what the limit as h goes to 0 from the left of f of 2 plus h minus f of 2 is. So my f of 2 plus h, if I'm coming in, so that's my 2x, minus my f of 2 we said was 4. Sorry, I just put 2x, but my x needs to be 2 plus h. Sorry. So 2 times 2 plus h minus 4 over h. So 4 plus 2h minus 4 over h, the 4's cancel. The h's are going to cancel. My answer is going to be 2. The limit, as h goes to 0 from the right of f of 2 plus h minus f of 2 divided by h. So this one, limit as h goes to 0 from the right, I'm talking about greater than, if I'm coming in with 0 from the right, 2 plus like 0.01 or whatever, it's going to give me greater than 2, which is going to be x squared, which is going to be 2 plus h squared, minus, and we said f of 2 is f of 2, so f of 2 is 4. And then you have to go to where the equal sign is on the function up here to find your f of 2 every single time. Limit as h goes to 0 from the right, so we've got 4 plus 4h plus h squared minus 4 divided by h. My 4's cancel. Limit as h goes to 0 from the right. I'm going to factor an h out and cancel it. And now when I put in my 0, when I put my 0 in, I get 4. So my derivative from the left is not equal to my derivative from the right. So that means it is not differentiable at 2. It is continuous at 2, but it is not differentiable because my left-hand derivative did not equal my right-hand derivative, okay, at 2. So therefore, letter B. Okay, number 26. find dy dx at x equals 2. Did you hear what I said? Find dy dx at, that line right there means at x equals 2, given that y equals the ln of x. And so we are going to say the limit